We now turn to the quantitative statement of the force law between two charges. The important features of this law were discussed by Charles Augustin de Coulomb in 1785, using the torsion balance shown to determine that the electrical force between two charged objects was inversely proportional to the square of the distance between them. Consider two charges, Q1 and Q2, that are separated by a distance r12 as shown. The force that charge 1 exerts on charge 2 is directed along the line connecting the charges and is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them. Note that we've drawn F12 as a repulsive force. Our notation here is that the first index refers to the charge that exerts the force, and the second index refers to the charge that experiences the force. In other words, F12 is a force by 1 on 2. Since F12 is repulsive, we know that the charges must have the same sign. If we treat Q1 and Q2 as sign numbers, then the vector form of Coulomb's law shown determines the correct direction automatically. I.e., if charge 1 and charge 2 have the same sign, the product Q1, Q2 is positive, and the force is repulsive, i.e., along R12. If charge 1 and charge 2 have opposite signs, then the product Q1, Q2 would be negative, and the force would be attractive, i.e., along minus R12. We now write the equation for F12, the force by charge 1 on charge 2, and compare it to the equation for F21, the force by charge 2 on charge 1. Note that these equations directly demonstrate Newton's third law. Since R12 is equal in magnitude but opposite in direction to R21, the force by charge 1 on charge 2 is equal and opposite to the force by charge 2 on charge 1.